Hello everyone, welcome back. In this episode, we will explain how to rewrite the dynamic bicycle model (dBm) into a state space equation under the FS coordinate system. This figure shows the dBm, which includes the tire slip angle and the cornering stiffness. Therefore, it can be applied to high-speed driving conditions. This is the rewritten result from the paper. We only need to derive these two terms, fpy dot and theta f, the second row and the fourth row. The rest of the other parameters are simple. And also these coefficients. Let me point out upfront that there are errors in these coefficients, so please pay attention to our derivation process. First, establish the 2DOF dynamic equations in the base coordinate system. Let me zoom in this screen. First, establish the 2DOF dynamic equations in the base coordinate system. M times M is the mass of the vehicle times Vy dot plus V times gamma. Here, this equation is vehicle's lateral acceleration. Let me give you a short explanation. Imagine this is a curve and this is a plane wheel of a vehicle and this is the speed. At this time, the vehicle slip angle is 0. So the lateral acceleration is V square over R. R is the curve's radius. This is R. And equals V times gamma. Gamma is yaw rate. Gamma is yaw rate. In this situation, at the slip angle is 0, it's called circular motion. And when the vehicle goes to here, the tangential speed is v, and this is the vehicle. So this is the headline of the vehicle, and also in the base coordinate system, this is xb axis, and this is yb axis. So this is the slip angle. This is not 0. And the projection of the speed v on yb axis is vy. So this is called translational motion. At this time, the lateral acceleration equals vy dot. And also, vy equals sine beta times v. Because the beta is quite small, so this equals v times beta. We will use these equations later. And the lateral acceleration, the total lateral acceleration equals the translational motion plus circular motion. This is Vy dot plus V times gamma. Actually, I have explained these equations in my previous episode. Please search 2DOF so you can find the detail of this equation. Okay, continue. Equals 2 plus FF plus 2 plus FR. Here, FF and FR are front and rear tire lateral force. So this is the first equation. Okay. Next, the FF equals KF times delta minus Vy plus LF times gamma over V. Here, KF is tire cornering stiffness. Cornering stiffness. And delta is steering wheel angle. Here, this angle is delta. And Vy over V. Vy over V. This is beta. Actually, this is the slip angle at the center of the vehicle. And LF times gamma over V. This is LF times gamma over V is this angle. So this is beta and this is LF times gamma over V. These two angles, sum of these two angles together and minus delta is this angle. This beta F is front tire's slip angle times cornering stiffness equals front tire's lateral force. So the same in the rear. FR equals KR times LR times gamma minus Vy over V. This is LR times gamma over V, this angle, and this is Vy over V, beta. So the result is beta R, this angle. This is beta R is the rear tire slip angle. Okay. Combine, replace FF and FR into equation 1. We can get, let me erase the screen. Replace FF and FR into the equation 1. We can get M times Vy dot plus V times gamma equals 2 times Kf times delta minus Vy plus Lf times gamma over V plus 2 times Kr times Lr times gamma minus Vy over V. Continue, equals 2Kf times gamma minus 2Kf times Vy over V minus 2Kf times Lf times gamma over V plus 2Kr times Lr times gamma over V minus 2Kr times Vy over V and equals 2Kf times gamma minus group Vy together 2Kf plus Kr over V times Vy and then group gamma terms together minus 2Kf Lf minus 2Kr times Lr. Group them together times gamma over V. Okay, so in the left side, this is M times Vy dot plus V times gamma. Divide M on both sides, then move V times gamma to the right so that the V dot equals 2kf over m times delta minus 2 times kf plus kr over m times vy over v, this term. Then the 2kf times lf plus 2 times kr times lr over m times gamma over v. Don't forget, we have v times gamma minus v times gamma. Okay, here this coefficient equals b1. This coefficient, actually here, let me move this picture. Let me move this figure here. So this coefficient is b1 here, and this coefficient is a11. Without this negative, it's a11. And this coefficient a12. This is a12. Okay, so we can now we get a11, a12, and b1 coefficient. We can rewrite this equation in a simple way. Let me move this diagram here. So y dot equals b1 times delta minus a11 times vy over v minus plus a12 times gamma over v minus v times gamma. Okay, next we need to replace vy dots vy and gamma. So first vy equals, just now we have derived vy equals v times beta. Then the gamma equals, in last episode we explained gamma equals theta f dot plus theta f theta f dot plus theta ref dot. In last episode, the gamma we use theta g dot to represent, so please check it out. And this equation goes to theta f dot plus v times the curvature of the trajectory ref times cosine theta f plus beta over 1 plus rho ref, the curvature, times fpy. You can check this equation in last episode. Here, 1 minus rho ref times fpy equals 1 because the rho ref is quite small. And here, the theta f plus beta is also quite small, so this equation the cosine equation is also 1. So it goes to theta f dot plus v times rho ref. Okay. Next, so we get the gamma equations. Next, fpy dot equals v times sine theta f plus beta. This is also we derived in the last episode. Equals, because the theta f plus beta is quite small, so it equals v times theta f plus beta equals v times theta f plus v beta. V times beta is vy. So it equals v times theta f plus vy. And so the v fpy double dot equals vy dot here, vy dot plus v dot times theta f plus v times theta f dot equals vy dot plus acceleration. The v dot is acceleration times theta f plus v times theta f dot. Okay. Now, in this equation, we call this is equation 2. This is equation 3, 4, and 5. We replace gamma in equation 3 and vy in equation 4 and vy dot in equation 5 to replace in this equation. We can get the fpy double dot minus a times theta f minus v times theta f dot. This equation is vy dot equals, in here, b1 times delta minus a11 over v times vy is here. Vy is fpy dot minus v times theta f plus a12 over v times the gamma here. Gamma is here. Theta f dot plus v times rho ref and minus v times gamma theta f dot plus v times rho ref. So it equals b1 times delta minus a11 over v times fpy dot plus a11 plus a11 times theta f, these two equations, plus a12 over v times theta f dot plus a12 times rho ref minus v times theta f dot minus v square rho ref. Okay, so let's combine the theta f and the theta f dot together. First, here v times theta f dot. These two terms can be delayed, and then we move the a times theta f to the right side and group the theta f term together. So the fpy dot equals minus this term a11 over v times fpy dot plus next this term and this term, group them together, a11 plus a times theta f. Next is the theta f dot plus a12 over v times theta f dot. So the next is b1 times delta plus a12 minus v2 times rho ref. Okay, so let's compare to the equation in the paper. This coefficient a11, a12, and b1 just now we have derived. Then you can see this is the fpy double dot. fpy double dot. This is the same as we derived here. Here, a12 minus v2 square is in the E matrix here. So the first mistake in this paper, the rho ref, it has two rho ref. So this rho ref should be removed. This might be a typo. And in the B matrix, this is B1. Here, this is B1. B1 times delta. So the fpy dot we have derived. Next is theta f dot. Here, this equations. As the same with fpy dot, first we build the yaw moment about z-axis. So the iz times gamma dot. Gamma is yaw rate, and iz is yaw. Iz is yaw inertia equals 2 times ff times lf minus 2 times fr times lr. Let's see in this diagram. LF, the CG to the front axis, and LR, the CG to the rear axis. This equation is the yaw moment about CG, z-axis. Okay, so just now we derive FF equals KF times delta minus Vy plus LF times gamma over V, and FR equals KR times LR times gamma minus Vy over V. So replace these two parameters into this equation. We can get, so the equation goes to Iz times gamma dot equals 2 times Kf times Lf times delta minus Vy plus Lf times V over V minus 2 Kr Lr times Lr gamma minus Vy over V. And 2kf LF times delta minus 2kf LF times Vy over V minus 2kf LF square times gamma over V. This is gamma. Minus 2k RLR square gamma over V plus 2k RLR V, times Vy over V. And this goes to group Vy term and gamma term together. So 2kf LF times delta minus Vy term here goes to 2 times kf LF minus KRLR over V times Vy minus 2 KFLF square plus KRLR square over V times gamma. Next, both sides divided Iz. So the gamma dot equals 2KFLF over Iz times gamma plus 2KFLF minus KRLR over Iz times Vy over V plus 2KFLF square plus KRLR square over Iz times gamma over V. This is square. Okay. So this let's compare to the equation in the paper here. Okay. This coefficient is B2 and this coefficient is A21 and this coefficient including the negative is A22. So let me remove the coefficient, erase this line. So the equation goes to gamma dot equals B2 delta minus A21 times Vy over V plus A22 times gamma over V. Okay, next, remember we derive gamma equals sig f dot plus V times rho REF and gamma dot equals CF double dot plus A times rho REF plus V times rho REF dot. This term is quite small, so remove it. Remove it. Only keep these two terms. And Vy equals FPY dot minus V times theta F. Replace gamma dot, and Vy to this equation. We can get, let me move the screen. The gamma dot, the gamma dot equals theta F double dot plus A times rho REF equals B2 times delta minus A21 times Vy is here is over V times FPY dot minus V times theta F plus A22 over V times theta F dot plus V times rho REF. The set F double dot equals B2 times delta minus A21 over V times FPY dot plus A22 here, sorry, plus A22 times set F plus A22 over V times set F dot plus A22 times rho REF. And don't forget minus A times rho REF. So the equation set F double dot equals A22 over V times FPY dot plus A21 times theta F plus A22 over V times theta F dot plus, put it together, A22 minus A times rho REF and plus this B2 times delta. Let's see the equation in the paper. This equation is same with this, and the E here, the E matrix is this A22 minus A here times rho REF, and B times rho is this coefficient. So obviously minus A, this is a typo. This should be removed. Only keep B2. Okay, now we complete this equation of dBm mode transform in the fs coordinate system. So in the next episode, we are finally going to explain what is MPC, and how to transform KBM or dBm into MPC. So see you next episode.